So let's just go ahead and jump in and take a look at some examples of these in the presentation of data sufficiency questions. So we have a data sufficiency question here. Let's do our 1, 2, 10. Great. How much is 10% of a number? Let's translate that from English to math. How much, which is what we're trying to figure out, is the same as an equals. 10%, this is how you write 10%. Of is the same as multiply, and number, let's just say x. So how much is 10% of a number? Okay, they want to know how much is 10% of this number. Let's take statement number 1. 20%, let's write it as math, 20% of the number x is 40. So if we know that 20% of a number is x, 20% of x is 40, and we want to figure this out, do we have enough information to figure this out? Yes or no? Do we have enough? This is not a data sufficiency yes-no question, but we don't need to do more math than we need to know to answer their question of how much is 10% of a number. Is this enough information to tell us what that is? What do you think, Jake?
I think so.
You think so? Jake thinks so. I'm going to go with it. This is enough information to let us know. We have an equation here. We can solve for x. We can plug x back in here, and it'll tell us how much is 10% of that number. What do we get rid of? If 1 is sufficient, we can get rid of 2. We can get rid of t, and we can get rid of n. Very good. Let's test the second statement. 50%, don't do English, do some math here just to lay it out. We're not even crunching numbers, we're just writing it out. 50% of the number is 100. This looks like it's the same situation here. We have 3 things. Remember, 50% of the number is something. So I got all my pieces. And just like the first equation, if I can solve for x here, I should be able to plug it in here and find out how much is 10% of a number. So I'm pretty sure the answer is each statement alone is sufficient. And we're correct. So that was a data sufficiency meets percent question. There's always 3 pieces. Write things down, analyze it. We just sort of translated the English into the math so we could see it as math, and we could apply our rules of the number of equations we have, the number of unknowns we have, and whether or not that's sufficient to give us the information we need to. And we never actually did the math to figure out what x was or what the question mark number was either. We just got it to a point where we knew there was 1 question and 1 unknown. Let's take a look at an average question here. I think this is an average question. It's a data sufficiency, so go ahead and give yourself the 1, 2, 10. Whoops. 1, 2, 10. I'll give you a second to read it, and then we'll break it down and work the statements. So I'm pretty sure, even though they don't talk about the word average, they say every member of Meg's immediate family agrees to share equally. So that's like the average. They're going to break it up equally. The cost of her wedding. So I know average questions always have 3 pieces. The average, the total, and the number of things we're dealing with. So that's what they're asking for, is the number of things we're dealing with. How many people are in Meg's immediate family? And I said F for family. And the total is $18,000. They told us that. And average I don't know, and I don't know this. So I don't have enough information currently to tell you how many people are in Meg's immediate family. So let's take a look at statement number 1. Everyone in Meg's immediate family will pay $1,500. So their contribution, or their average that they pay each, will be $1,500. So that would give me an equation like this. 1,500 equals 18K over f. Now, I can solve for f. Do I need to? Do I need to solve for f, Jay?
I don't think so.
I don't think so. All I need to know is whether or not I can solve for f. And if so, then I know that statement 1 alone is sufficient. And which answer choices can I get rid of? I can get rid of 2, I can get rid of t, and I can get rid of n. Down to a 50-50 answer choice. Not too bad. So let's test out 2. If 4 immediate family members do not contribute their share, slackers, each of the other family members will have to contribute $750 more than if everyone had contributed. It's written in English. It's kind of confusing. I noticed that I didn't have to do a lot of math. I just kind of translated it into some math. Let's see what this means. If 4 immediate family members do not contribute, so we take f minus 4 is the number of family members in this situation. And we said c was their contribution. So this would be c plus 750. But the total is still the same. So what did we say? The average, which is, in this case, c plus 750, is equal to the total, still the same, by the number of people. This time it's 4 less. So if 4 fewer people pay 750 each more, we still have a situation where now, in this situation, what did we have? We had 1 unknown and 1 equation. We can solve for f. Here, we have 1 equation and 2 unknowns. So I don't think we can solve. But there's another equation over here. Remember, we said c equals average. So here's one equation that's valid, that c equals 18k over f. And here's another equation that's valid, that c plus 750 equals 18k divided by f minus 4. I have 2 equations, 2 unknowns, so I think I have enough information to figure it out. Jake, should we take like the minute and a half it takes to solve this question?
Not on the test.
Not on the test. If you're practicing for homework, it's not a bad idea. But I'm pretty sure both of these statements alone are sufficient. We got a pretty good streak here going. Let's see if we get that right. Nice. So it's 7 o'clock. If you have to get going, we understand. We're going to continue on. We're going to work a couple of more questions here. If you have to get going, we will see you on Saturday. You can... To let you know, your homework is just going to be the issues that we covered today. It's going to be 15 data sufficiency questions, 5 average questions, 5% questions, and doing a bunch of group study as much as you can all week. But if you want to stick around, we're going to keep going and work a couple of more questions. Thanks a lot for joining us. We hope you've had fewer technical difficulties today than you had last week. If you had any, the course will be available for purchase and to restream these second and going on episodes. That said, let's go ahead and continue and work a few more questions together here. If you notice, this one is not a data sufficiency question, so we don't need to do the 1, 2, 10. But let's go ahead and use our same techniques, parse the language, analyze it, break it down, re-represent it on our own, on our scratch pad. If a shipment, this is a good question actually, if a shipment of eggs consists of 36 white and 89 brown eggs, how many brown eggs must be removed so that 72% of the eggs in the shipment are white eggs? So how many eggs will be in the shipment if 72% of them are white eggs? We said in percent questions that we have how many pieces here? Let's go ahead and look. Percent, the number of things we're counting, and the total number of things. Let's replace what we know. So we know that 72 is the percent. We know that the number of things that we're counting is 36. And we want to figure out how many things there are, right? 36 is reword it this way. We can go from English to math. 36 is 72% of what number? Okay, so let's multiply. We get 3,600 equals 72x. We divide both sides by 72. We get x equals, there's a little math to do here. Everyone take a quick moment and crunch the math here. Do you know what the number is, Jake?
I think it's 50.
That is correct. Nice work. X equals 50 should just be about 15 seconds or so of arithmetic crunching there. X equals 50. So 36 is 72% of 50. So if we have a total of 89 brown eggs, and we need to get to a point of, we have a total of 50 eggs. How many brown eggs do we need to get rid of? So 36 plus 89 is what, everybody? Go ahead and type it in the chat box while I do it. 6 plus 9 is 15. 4 plus 8 is 12. Did I do that correctly? Now we want to get to 50. We started at 125. We want to get to 50. So it looks like we lost 75 eggs, and since we're only removing brown eggs, this is the number of brown eggs we have to get rid of. Nice. Great job there.